Hey guys, so today we'll talk about numericals. We have seen what lens formula is. Today we'll also see how do I use it to solve a sum. In the last class I told you to take a look through the sign convention, correct? Which we learned in mirrors chapter. If you went through it, excellent. A quick run over is it has 4 rules. It talks about how to measure distances. So that is for F, U and V, right? And also tells about height of image and object. So to keep it simple for us, I have shortened it down to this. Okay. So if you remember this, it's sufficient to do sums over here. Okay, I'll just show you what these are. So it says V, that is nothing but image distance, is positive if the image is real. Okay, and we know real images come in mostly convex lenses for 5 cases. Except for between F and O, everything else is a real image, right? Inverted and real. So in all those cases when you get a convex lens and the image is going to be real, definitely we can get the positive sign over there. And if it's a virtual one, like say a concave lens or one of the convex cases, it will be minus sign for that number. Okay, U is always negative because the lens is here, the image is behind, right? So we measure towards the left, but the light is always going from the right, left to right. So that tells me that definitely U is always going to be negative, no matter what sum we take. And for focal length F, it's always a positive number for a convex lens and a negative number for a concave lens. Simply because for convex lenses, we use a focus on the right side. Light is on the right, towards right, focus also right, positive. Concave, we use the focus on the left side, which is why it is negative. Okay, just remember these 5 points, that should be sufficient to understand and use. Okay, so now I will read out the sum for you. A concave lens has focal length 15 centimeters. At what distance should an object be placed from the lens to get image at 10 centimeters, and also find the magnification. So again, as we always do, we'll first write what is given to us in the sum, right? Straight up it is focal length 15 centimeters, right? So I can write F equals to 15 centimeters, right? Now we need to decide which sign to give this number, right? So if it's convex, we give positive, concave, negative. Whereas it is concave lens, so it is negative. So definitely my F is minus 15. Okay, you saw how to use it. Cool. For the next one, at what distance should an object be placed? So they're asking what should the object distance be to get image at 10 centimeters, right? So they're saying V should be 10 centimeters. Okay, so if I have to draw the diagram for this, it would look something like this. Okay, I'll just put a small diagram. So there will be like concave lens, this is F, C and C, and this is 15 centimeters, means the object would be somewhere here, 10 centimeters, right? So this can be F. Anyway, it hardly matters because we know always concave lenses will give you virtual images, always. So that means this V is minus 10. Okay, this is how we use the sign convention. Now we need to figure out what is u. We'll use the formula that we know, that is Lenz's formula, which says 1 by f equals to 1 by v minus 1 by u. Okay, the order is important. First it is v, then it is u. Okay. Now, if I place the values 1 by f, or let me do one thing. First, I rearrange because I need to find u. So I'll bring u to this side. 1 by f plus 1 by u equals to 1 by v. Right? I moved it from right to left side. Now I will take the f and take it to that side, meaning 1 by u equals to 1 by v minus 1 by f. Okay, it's always easier to first rearrange then substitute the numbers. So now I have u on one side. 1 by u equals to 1 by 1 by minus 10, right? Minus of 1 by f, which is 1 by minus 15, right? So if I solve this, 1 by minus 10 is nothing but minus 1 by 10, minus 1 by 10. This minus goes up, minus into minus, right? So becomes plus 1 by 15. Okay, so that is 1 by 15 minus 1 by 10. So how much would that be? What if I do fractions, right? Do the fractions carefully. I simply put this as 15 into 10 multiplying, and I do butterfly. Minus 15 into 1 or minus 1 into 15, same thing, plus 1 into 10. Now to do the butterfly method, I hope. So minus 1 into 15 nothing but minus 15 plus 10 divided by 150. Nothing but minus 15 plus 10 is minus 5 divided by 150. Now I have two fractions. I can reciprocal. You know what reciprocal means, right? So u equals to minus 150 divided by 5. Right? I just put the denominator up and the numerator at the bottom. 5 3 is 15, 30. So u equals to minus 30 centimeters. As simple as that. So now we know that if you put the object at 30 centimeters distance, then the image will be at 10 centimeters. Now the minus simply tells you that it's on the left side of the lens, and like I said, u is always going to be negative number, so it's kind of correct. Alright, so next part of the sum asks you to find magnification, right? Now for magnification also we have a formula, v divided by u. I will not use the other number, obviously I don't know the height of image and object, right? So I can simply write this, what is v? minus 10 divided by minus 30 equals to minus and cancel, 0 and 0 cancel, which is 1 by 3. So m equals to 1 by 3, or I can write it as 0.3 bar, 0.33 take continuously. Right now, whenever m value is less than 1, it means the image is smaller. If m value is greater than 1, it means the image is bigger. If it's equal to 1, then it means same size. Okay, so image is smaller than object. This much I can do. And we know this is true because concave lens, that is always the case. All right. So this is a completed solution for this whole sum. Right? It is simple stuff, not much. Just keep these rules in mind. Read the question carefully. Do the number part very carefully, especially because their fractions tend to make mistakes here. Make sure our fractions are well. Okay. Alright. So that's it for today. I'll see you in the next class. And also, if you are not able to hear my voice clearly, please leave a comment down below. We're trying to fix that also. Okay. Bye bye.